as we move out of the age of fossil fuels towards cleaner energy alternatives, we need to ask, does gas have a role to play in our future energy mix? And how do we ensure that we can maximize existing gas assets in a way that is sustainable? To answer these questions and provide insights into how US-based plant operators are meeting the decarbonisation challenge, I'm joined by Jeff Benoit of PSM, a Hanwha company. Jeff, thank you so much for joining us today.
You're quite welcome. It's great to be here. Thank you.
Let's talk about gas. Does gas have a future in our energy mix?
Wonderful question. Thanks for asking. The answer is absolutely. One of the things that I've been trying to do is, and for others in the industry, is to get them to appreciate the purpose of natural gas in the industry. Gas turbines, we feel, represent the technology to help bridge the transition from today's current state to the clean energy transition. And the way we're going to do that is with gas. And because of the dispatchability, the firming capacity of gas, one of the things that it can do is it can balance out and complement renewables so that you can bring on more renewables while maintaining the reliability you need for the grid. So we see it being a wonderful transition solution.
What are some of the key challenges, Jeff, that plant operators are facing? Because obviously we're in a changing, decarbonizing world. So even though you say gas has an important role to play as a bridging technology, it's a challenging landscape.
It really is. And one of the things is with gas turbines, I would say a generation ago, gas turbines were viewed as base load assets, particularly in the United States. Here we are with just a tremendous amount of renewables being put into the portfolio. And the question the plant operators are asking is, how do I balance out renewables? They're cheaper than natural gas. They're going to get called first. So how can I provide the right solution, and who can I talk to who can provide the technology that turns these from just base load running assets to something much more nimble and flexible? And the way that is done is with retrofits and upgrades, taking the problem that the operator has and then simply turning that into something that can be dropped into the unit to allow them to participate effectively, properly, profitably, reliably in the marketplace.
You talk about retrofitting, and that is a great segue into my next question, because I'm quite keen to understand where hydrogen fits into the picture. I'm not sure about retrofitting for hydrogen, if it's possible, if the market is ready for that. Tell us a little bit more, because hydrogen is a popular topic here in Europe. Not so sure about the US.
It's getting some more traction. I'm the eternal optimist, but at the same time, I'm a pragmatic realist when it comes to this. So where we are relative to hydrogen, we really are at the beginnings of the opportunities. We're not trying to look to replace natural gas. In the United States, it's been 80, 90 years to develop a natural gas pipeline. Makes it very easy for power plants to secure the natural gas. With hydrogen, we really don't have a purpose-built hydrogen pipeline. We do have hydrogen pipelines in certain parts of the country. So the question is how can we begin this transformation, finding the right opportunities for hydrogen to allow us to allow the gas turbine to become decarbonized with a pathway to full decarbonization. And that's really what it is that we're looking for. First opportunities for us, refinery off gas. You have petrochemical facilities that normally would flare their refinery off gas. It has hydrogen in it. There is going to be there's going to be regulations in place to have zero flaring, zero routine flaring. And with that, they have to look to do something with that. And one of the ways is to use it in a gas turbine. One, they don't have to buy natural gas. Two, it has hydrogen in it. And three, it can help to begin the journey to provide decarbonized power because the hydrogen will oxidize and burn without any greenhouse gas emissions.
So perhaps we're not going to see a giant leap into green hydrogen use off the bat.
Well, one of the things that's really stymieing this transition in the U.S. is the price of natural gas today. It is so incredibly cheap today because of fracking technology and the ability bring it out of the ground at incredibly low prices. Hydrogen today is very expensive, so that gap is one of the things that's kind of stalling out the momentum to bring hydrogen into power. So that's what one of the areas that we're looking at is how can we help with that transition.
Jeff, speaking of expensive technologies, I wanted to touch on carbon capture and storage to find out what's happening in the US market. That this is really an expensive technology and it's quite a nascent sector.
It is an expensive technology today simply because it's not commercialized. So the question is, can we begin the commercialization and the scaling of this? The Department of Energy has a number of programs today with existing power producers to put carbon capture into existing power plants. Now that necessitates putting basically an entire chemical factory to extract the CO2, to compress it, put it through a pipeline, and then put it into secure geologic storage. One of the issues is that you create a lot of parasitic load. It takes energy to run this factory. At the same time, that's going to drive down the overall efficiency. So the price of electricity is going to go up. I would say we are a number of years away, but I am quite optimistic that with these first programs, we'll begin to develop the technology needed for carbon capture. There are two ways to decarbonize a gas turbine. You either are going to take out the carbon from the natural gas from natural gas and create hydrogen and run that hydrogen in a turbine. So pre-combustion decarbonization, or you're going to do it with carbon capture on the back end of the gas turbine. Where in the United States, with the price of gas the way it is, there will be a very big push to drive carbon capture commercialization.
And there are some very promising projects on the horizon indeed.
Absolutely. I would say there are two that I'm quite familiar with. One in California, of all places, which is I'm very excited about. The other is in Texas. And there's been a lot of visibility, a lot of press, but those are the type of actual applications that investors are looking for to find out if and how they can bring that and invest to bring it to commercial phase.
And it's obviously critically important for investors to be able to have a line of sight on future revenues that these projects are actually going to commercialize at the end of the day.
That's absolutely right. It's critical. They need to see that there are players, there are service providers who are developing the technology to allow these assets to take advantage of hydrogen and these fuels. I spend a lot of my time with those in the midstream and upstream. And in the United States, it's going to be those who are going to reform natural gas into hydrogen, what we call typically blue hydrogen. It's plentiful, it's cheap natural gas, you can do that. Well, with that, once they reform it, what are the applications? One is going to be the production of ammonia for export. Ammonia is a very good carrier for hydrogen. The other is what domestic applications can there be? Yes, there can be fertilizer applications. It can also be used to desulfurize fuel in refineries. But where is that really good, solid source of demand for hydrogen? So I spend a lot of time educating and informing the investors to say, hey, if we can take the installed fleet and find the right applications first, where we can draw large quantities of hydrogen, there is, for you, is part of your business case and a good return on investment to allow you to get that much closer to FID.
That makes perfect sense. Jeff, we can't talk about the future of the gas power plant without mentioning AI and automation. In your opinion, how is this changing or disrupting the landscape?
That's really great. We embraced what we call digital solutions. And in that, I guess in our definition, it is a bit of artificial intelligence. This is a tool that allows the gas turbine to operate in regimes where it normally wouldn't be easy to operate in, but it allows the gas turbine to be more profitable while maintaining its reliability. I look at it as almost like a field of wheat, where you miss the corners of the wheat just simply because of the equipment you have. Well, AI allows you to harvest the corners, and in this case, harvest more profitability and allow the gas turbine to operate in a much larger operational range while maintaining your emissions compliance. We have a tool called AutoTune It's on over 100 gas turbines, and it autonomously will modulate the fuel-air mixture inside the combustion systems to balance out combustion dynamics or pulsations with emissions and monitoring the operational profile. And it's doing it, and it's self-learning. So in our view, it's the beginnings of AI. And I can see where AI can help with the power plant. Reliability is key, affordability is key. And these are the two areas that certainly our customers are looking for.
Well, Jeff, it's been an absolute pleasure to get these insights from you. I feel like we could talk more on automation and AI for the next hour, but for now we've run out of time. Thank you very much for sharing your
You're
insights.
quite welcome. It was wonderful to be here. Thank you.
And if you enjoyed the talk, please do feel free to subscribe to the Energy Transitions podcast. You can find more information at enlit.world.